everyone, thank you so much for coming to this video. So today we're going to be going over how to apply differential equations to some real life problems. So make sure you review the video on differential equations and how to solve them, as that will come into use for this video. So the learning objective for today is to be able to apply differential equations to real world contexts. So I'm going to go over two exam style questions and how this could come into use. So like always, there's going to be timestamps in the description of the video, so feel free to skip to any parts you want to. But let's get started. So we have an exam style question here, and feel free to pause the video and try it out for yourself using what we've already covered. So we have the diagram above shows a cylindrical water tank. The diameter of a circular cross-section of the tank is 6 meters. Water is flowing into the tank at a constant rate of 0.48 pi meter cubed per minute. At time t minutes, the depth of the water in the tank is h meters. There is a tap at a point t at the bottom of the tank. When the tap is open, water leaves the tank at a rate of 0.6 pi meter cubed per minute. So the first part is we want to show that at t minutes after the tap has been opened, 75 times dH over dt is equal to 4 minus 5h. So in order to solve a question like this, is quite complicated. You just want to write down any information you can. So we know that water flows in at 4.8 pi and flows out at 0.6 pi h. So that means that as volume changes over time, our dV over dt is just equal to how fast it flows in. So that's just 0.48 pi minus how fast it flows out, which is 0.6 pi h. And we also know that we can work out a volume would just be pi r squared h. And we know that our diameter is 6, that means our radius is just 3. So that would just be equal to our volume, it's just equal to 3 squared, so it's just 9 pi h. So now we can figure out, we can differentiate all of this over t, because we want to try to find out our dH over dt, because that's what we're trying to aim to. So if we differentiate both sides relative to t, we would get dv over dt would just be equal to 9 pi times dH over dt. So now we've got two expressions for dv over dt, so now we can just equate them together. So you'd get 0.48 pi minus 0.6 pi h is just equal to 9 pi times dH over dt. So now we can divide everything by 9 pi. So if we were to do 0.48 divided by 9. So now we want to try and simplify this. So we can cancel out pi. And now we can rewrite these decimal points in terms of fractions. So we could get 48 over 100 minus 60 over 100 is equal to 9 dH over dt. And then if we were to multiply both sides by 100, we get 48 minus 60 is equal to 900 dH over dt. And now we want 75. So in order to get 75 here, we want to divide everything by 12. So we would get, that means we would have 48 divided by 12, so that's just 4. So this was the h here, minus 5h is just equal to 75 dH over dt, which is what they want. Okay, so now we want to try and solve b. So it says when t equals 0, h equals 0.2. We want to find the value of t when h equals 0.5. So to do this, we want to try and separate our values to get all like the h expressions on one side and all our t's on the other. So we don't have any t's in like our equation, we just have everything in terms of h. But we can still try to separate this. So we have 75 dH over dt is just equal to 4 minus 5h. So now if we were to multiply everything by dt and divide everything by 4 minus 5h, we'd get 75 over 4 minus 5h dh is equal to, we'll just get 1 on this side dt. And now we can integrate both sides. So we want to try and integrate this 75 over 4 minus 5h. So if we try this, if we have an f of h is equal to 4 minus 5h, then if we try to differentiate this to find f dash of h, we'll just get minus 5. And to get what we have here, to get our 75, we need to multiply this by minus 15. So therefore, our integral would just be equal to minus 15 of ln 4 minus 5h, which is just equal to t plus c. And now we can just plug in our t equals 0 and our h equals 2 to find a value of t. So if we do that, we'd have minus 15 ln of 4 minus 5 times 0.2, 5 times 0.2, which is equal to, t is just 0, so that's just equal to c. So then if we do 4 minus 5 times 0.2, we'd get minus 15 ln 3 is equal to c. So then if we plug that in, we would get minus 15 ln of 4 minus 5h, which is equal to t minus 15 ln 3. And then we just want to find the value of t when h is 0.5, so we can just plug that in to get minus 15 of ln 4 minus 5h, when h is 0.5, plus 15 ln 3 is equal to t, and that is equal to minus 15 ln of 1.5 plus 15 ln 3, that's equal to t. So that means t is just equal to 15 ln, remember if we have 15 ln 3 minus 15 ln 1.5, so that's just 3 over 1.5. So then our t is just equal to 15 ln 2. And that's your answer to this question. So the key, if you have like a really wordy question like we did here, was just splitting, we're just like writing out all the information you can in like some mathematical form, and then just like manipulating this to try and get what they want you to get here. And then you just solve it normally, plug in your values to find what they want you to find. So let's try one more exam question. So we have another exam question here. Feel free to pause the video and try it out for yourself first. So we have liquid is pouring into a container at a constant rate of 20 centimetres cubed per second and is leaking out at a rate proportional to the volume of the liquid already in the container. So the first part is we want to explain why at time t seconds the volume v centimetre cubed of liquid in the container satisfies the differential equation dv over dt equals 20 minus kv. So it's dv, so the reason why we have dv over dt, so that's just how the liquid or volume is changing. And then we have that is equal to how much is pouring into the container, so that's 20. And then because it's minus, it's like, because water's flowing out, that's why it's negative. And then because it's proportional, proportionality is always constant, so it's just kV. So this negative sign here is because it's flowing out. But then K is a positive constant because you want this whole term, to be negative. So if your K was negative, then it would be plus kV, not minus kV. So that's the answer to part A. So now if we move on to part B, we want to, it says by solving the differential equation, show that B equals A plus B to the power of minus KT, giving the values of A and B in terms of K. So to do this, we want to separate the variables by putting all the variables of V in one side, all the variables of T on the other side. So similarly, like before, we don't have any for t, so we can just divide everything by 20 minus kv and multiply both sides by dt. So you'd get 1 over 20 minus kv dv is equal to 1 dt. And then if we integrate both sides, so now if we were to integrate 1 over 20 minus kv dv, so if you think about, if you have like f of v is equal to 20 minus kv, and if you were to find the derivative of that, you would get minus k. So to get 1, you want to times it by minus 1 over k to get 1. So this would be equal to minus 1 over k ln of 20 minus kv, which is equal to t plus c. So now that we have this, we want to, in order to get this form, we want to try and find out our value of c, our constant. And we know that because it says the container is initially empty, so we want to find our value. So at t equals 0, our volume is equal to 0, so we can plug those values in to find our c. So that means minus 1k of ln 20, that's just equal to c. So now we can plug that in and rearrange. So we can have minus 1 over k ln of 20 minus kv is equal to t minus 1 over k ln 20. So now if we were to add 1 over k ln 20 to both sides, we'd get 1 over k minus ln 20 minus kv, and then this would add, so plus ln 20, that's equal to t. So that means we'd have 1 over k of ln 20 over 20 minus kv, that is equal to t. So now we can multiply k by both sides. So we'd have ln 20 minus kv is equal to kt. So then we can add, like take the exponent of both sides. So we'd have 20 over 20 minus kv is equal to e to the power of kt. And then if we divide both sides by e to the power of kt and times both sides by 20 minus kv, we'd have 20 over e to the power of kt is equal to 20 minus kv. And we want it in the form that they've given you, so we want v is equal to something. So then we would have kv is equal to 20 minus 20 e to the power of minus k over t. So that means v is just equal to 20 over k minus 20 over k e to the power of minus k over t. And that means you have your a is equal to 20 over k and your b is equal to minus 20 over k. And that's your answer to this question. So yeah, it's just solving your differential equation as you normally do, and then it's just a lot of manipulation to try and get it in the form that they want you to do it in. So that's everything. Thank you so much, everyone. Hopefully you found that useful, and you can now apply differential equations to real world context. So make sure you do some more practice questions just to make sure you fully understand how to do this.